Okay, Mary, I think this is just for you. Section 2.2 histograms. We're going over, and I think we should get done with these notes all today. It's only 2 pages, so here we go. Starting with histograms, let's talk one real quick thing. Let's talk about a frequency table. Write this at the top. Frequency table. Let's say I have, let's talk about a test grade. Okay, test grade, and then I have my frequency over here. Okay, let's say my lowest test grade was like a 62. I have no idea. So we'll go 60 to 69. We'll go 70. Whoa. Actually, can I erase?
No, you cannot.
Let's go 61 to 70. Let's go 71 to 80. We'll go 81 to 90, just so we end up getting the 100 mark. 91 to 100, right? Okay?
You're going to get better with this.
Okay. You guys just need to write like 5 seconds behind me. What are you talking about?
10, 91 to 10.
Well, it erased. Whatever. Okay. All right, there were 3 students that scored in here. You pick who they are. I don't care. 3 students that scored in there. I can tell you a couple. All right. Let's say we had 5 students in this range. We had 9 students in this range and 11 students here. Okay? Okay. If I graph this, how is this skewed?
Left. Skewed left.
It is left skewed, right? Because it will look something-ish like this, right? Okay? Something like that, right? Where my towers are here. What we're going to be doing today is we're making that histogram, right? So a histogram is like a glorified bar chart, basically, is what it is, okay? So a histogram is just graphing a frequency table. That's what a histogram is, okay? So characteristics of a histogram. It is a graph of a frequency table. Okay? So your x-axis is your classes, and your y-axis is your frequencies. Okay, x-axis is your classes, y-axis is your frequencies.
What do we call these in calculus?
What?
Like, didn't we do something like this? Didn't we have an equation? Something
Yeah,
like
what was
this?
that called?
What?
Like we had rectangular.
Oh, kind of, yeah, exactly.
What was it called?
Like just approximating the area under a graph, under a curve.
Using the derivative.
Yeah, no.
Right?
Yeah, antiderivative is what approximates the area under a curve. Yeah. But if you can't do that, then you do the rectangular method to try to approximate instead. Yeah. Okay, one thing. Put a little star here.
No.
The bars touch. Okay, and I'll talk to you why here in just a second. But the bars of a histogram have to touch each other. All right, here we go. So let's just graph what we have up above here. We have test grades and we have frequency and all of those things, okay? I'm going to graph that here on my histogram. All right, and what I'm going to do is I'm going to do one of these. Have you seen that symbol before?
Yeah.
Because my first class is starting at 61. Okay, so here are 2 different ways that you can graph this. You can say 60 is here, 70 is here, 80 is here, 90 is here, and 100 is here. That's one way of doing that, of graphing it that way, okay? I don't care how you do it. Or you can do it like this. Where you say this is 61 to 70, 71 to 80. Do you see the difference? 81 to 90, 91 to 100, right? So I don't care which method you use. You will probably experience both in this section or in this whole chapter. I don't care which one you use, okay? But then over here, we have to label, okay? So what is this bottom?
Grades.
Test grades. You must label your axes. Test grades, okay? Then over here on the left side is frequencies. Frequency. I'll just say frequency. AXES. Axes.
Why not no one?
What?
Why is there not axis?
Axes. I don't know.
Anyway, sorry.
Yeah, that's very interesting. Oh, wait.
Yes, ma'am.
AXEX axis.
Okay, frequency. When you're doing a frequency for a histogram, I'm going to look at what my highest frequency is. 11. So let's go 12 as our top number, right? Okay, and the reason why I choose 12 is because it's an even number, and then it makes it really nice to do this. Half of 12, which is there, I'm like eyeballing, is 6, right? And then I'm going to separate that into 3 chunks. 1, 2, 3, and like that. So I've got 2, 4, 6, 8, 10, 12. You see how I just did that? If you want to go by ones, you can do a little smaller, even yet so little tick marks, okay? But I usually pick an even number, and then I do the half of that, right? That type of thing, okay?
Halvesies.
Halvesies. Good? Beautiful. All right, 60 to 70, was there 3 of them?
Yep.
So I'm going to do my bars. Here is this, and I'm going to go over, and that's 3 right there,
Hold on.
okay? Then I had 5. Is there 5 in the next chunk? Okay, and you can make this real pretty, or you can just do whatever, but make sure I can read them. Is it 9 next?
9,
Ooh, this is hard for me on a screen. I would normally like turn my paper sideways, but I can't do that. Okay, 9 and 11.
Make your fancy
I know, I should. Whoop. There we go, straight down. Yeah, but then I'm not straight down. Whatever, it's fine. And sometimes you'll see this happen 3, 5, 9, 11, whatever, right? And now you can definitely tell that he is like a whatever bell curvy thing, right?
Yeah.
Not a bell curve, but like a skewed right, or skewed left, I mean. Skewed left, skewed left. Okay, that's what he looks like. All right, got it? Now, why did the bars touch?
Because otherwise it would be like a gap.
No, because if it was 68 to 60 to 68, and
Because the classes, there's gonna be a gap in the class.
The classes are right next to each other. Like where one class ends, the next one starts, right? So that's why the things touch each other, okay?
have it overlap.
No. Nope. Nope. Nope.
No, because then where would you put the data? You can't put it in the-
Right, that was like one of the questions you had on the homework assignment where 120 or something was like repeated twice. You can't have that. Okay. So no overlaps. So there we go. Test grades frequency, that's a histogram. Yay, you just did your first histogram. All right. Let's talk about histograms over here. They have important uses of histograms. I'm zooming in. Here we go. The visual display of a histogram shows the distribution of the data, okay, or distribution. We had 3 types of distribution. I'm going to put them down here. We had normal. We had skewed right.
And left.
And then we had skewed left. There is actually
Another one.
one more.
9.
Uniform.
And it is uniform distribution. Is it down below?
Yeah.
Haha. Okay, normal distribution looks like this. Whoop, a bell curve. He is nice and pretty. Skewed right has the hump on the left. Skewed left has the hump on the right. Okay, uniform looks like this all the way across. Okay, we'll talk about here in a minute when you would have like a uniform
can
data.
You wait a second, please.
So it would look like that.
Wait, what is it? Why is there? What's the underneath? I don't get it.
It's like when your bars are shaded. So like all my bars would be the same height.
Look
Does that make
down
sense?
below, Ellie.
If you look down below, you'll see a graph of a uniform one.
Bars change a little bit, but
When would we have that?
What if it's like what?
And you,
A U?
Upside
You
down.
will never
What do we
probably
call
see
that?
that.
parabola.
I guess that would be maybe we don't ever have that happen, but that would maybe be like, okay, let me give you an example of when we would have that. Okay, like let's say I have this going on here, and then I have this going on here, right? Okay, that's a gap, right? And this would be like the pennies situation, right? Where we have 2 different time periods that the pennies are being taken from. Okay, otherwise you will not experience that. Okay. You will not get that as a graph. Okay. All right. So there's my 4 different types of distribution. You can. So number 2 here, it says shows the location of the center of the data. Like if I look here, I can see the center of the data is about like there. Okay. And I judge center by looking at area, right? If I put the center there, is this area about the same as all of those added together? Maybe. I mean, I might have to shift him to the left a little bit more. I don't know. Center of data maybe there, right? where this amount is the same as this amount. I don't know, but the center is probably going to be somewhere in this range, right? Ish there. That will tell me where approximately my center is. Okay? Now, center could mean, write this down. Center could mean your median, which is your middle number, or your mean, which is your average number. Okay? And we'll talk about the difference between the two. But median or mean, your middle number or your average number. A lot of times when they say center of data, they could mean either one of those. They don't mean the same thing. Mean is not the same thing as median, but a lot of times they'll say center of data, and you can kind of pick and choose which one you're going to use, the median or the mean, okay? It shows the spread of the data. So how far apart, how spread apart? Okay, it tells how spread apart your data is, okay? And that type of thing. And then it identifies an outlier. Do you know what an outlier looks like on a histogram?
It's like, I don't know.
Like way up or way down?
Like do 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 do
And then
do.
it goes short, and then it goes all the way over.
One of those. There's like one right here, right? Or maybe on the other side, right? That's what an outlier might look like. But you can identify that outlier from a histogram real easy, right? Because there's just one little guy off to the side, right? Okay.
Or like a outlier that's like, is on a really small guy, yeah, random.
No, because then he wouldn't be an outlier. Because there'd be more than one of them.
Oh.
Right. Yeah. Okay, how about that? All right, now, real quick, before we move on, they have two things happening here. Ready? Look at these two graphs and look at the difference between the two. They look the same. One of them is a histogram. Okay? And a histogram we said was frequency versus whatever it is you're talking about, right? Then we have a relative frequency histogram. What's relative frequency, by the way?
The percent.
The percent. What happens when I do frequency and then I change it to percent?
Nothing.
Nothing. It doesn't change how the bars are. It just changes what your labels are. Does that make sense? Yeah, it doesn't change what your bars are. It just changes the labels. Got it? What are you doing? You're not paying attention. I know you're not. Okay, good. All right, so just know that when you convert to a percent, it doesn't change. All right, here we go. Let's talk about circumstances and when a normal distribution might happen. So when you have data that's going on here, when might you experience like this type of flow thing going on? I'm going to choose grades for a different one.
Average height.
Height. Height might be one like this, right? You'll have most of the people that are here in the middle that are on the average height. And then you've got your really tall people over here. And you've got your really short people over here. Okay? And there's not very many of them, right? This is talking about frequency. So there might be like 3 tall people, 3 short people, and then everybody else is here in the middle, right? Whatever. Kind of distributed evenly, normal distribution. Anything else that you can think of? Weight would be like the same thing, right? I'm trying to think of what else.
A lot more.
Is it
What?
E before I?
EI, yep.
Even before I accept that first.
It's supposed to be I before E except after C.
Oh, never mind.
Yeah. But that rule is not correct anymore. Anything else should we put down for that? We might come up with some more examples here in a bit.
Oh, that's not right.
Let's talk about this. This is a uniform distribution. If you can't see this very well, there's uniform. I'm going to make this label bigger. UNIFORM. Make these bigger. Uniform. This is normal. Make those labels bigger, right? You can see them down below, but make this bigger so that you can identify them easier. Uniform distribution. When might this happen? I don't think so. What?
You don't think so?
I don't think so. When might something happen where you get the same number each time? Just about.
In an experiment. Maybe.
Right? In an experiment, like, I'm going to say, rolling a dice. Okay? Where this is rolling a 1, this is rolling a 2, this is rolling a 3, this is rolling a 4, this is rolling a 5, this is rolling a 6, right? And get rid of these numbers, right? And this is the frequency, the number of times I have rolled those. Those should be, if I keep rolling the dice over and over and over again and do like 1,000 rolls of this dice, I should have about the same amount of 1s, about the same amount of 2s, etc. Maybe not exactly, because you might roll a 3 more often than you roll a 4, but they should be about the same, right? Uniform. They're about uniform, okay? Okay? So think of like when the outcome might be the same for everything, right? Okay? Like flipping a coin, but you just have like heads and tails, right? That would be more of a category on the bottom here, but that would work also, right? Of when those things might happen. Okay? Got it? Rolling a dice. Okay? Let's go down here to this one. Here is what happens. This is a right skewed. Right skewed. Okay, this is a right skewed, okay? And this will happen. You will find that you have a right skewed graph if you have a lower bound. Okay? If you have a lower boundary, you will usually have right skewed data. Okay, I'm going to bump over to left skewed data. Let's say left skew. Okay, this is when you have an upper bound. Okay, and I'm going to do an example of this. And I'm going to put test grades here. Okay, I'm going to put test grades there.
Lower limit, upper limit.
Yeah, lower limit, upper limit. What's the upper bound for test grades?
100.
Usually 100%, right? Okay, and we're hoping that test grades are left skewed, which means the majority of people are scoring up close to that 100% mark, and then there's very few of you, although there's Eli's that lives over here, that are on the tail end, right?
Whoa.
Whoa! Oh, he's paying attention.
That's
Okay.
That's my.
Sure.
That's my homework grades, not my test
Sure.
grades.
Right. Okay. Right. Well, whatever. Okay. So we're hoping that kind of thing happens, right? With test grades, that might be an upper bound. Okay. What about? And I have to sit and think about this for a little while. What about the lower bound? What about right skewed? What's an example of when that would be?
What if I said population? Like, I don't know, I feel like there's more people in there, like in more, like in, I don't know, some areas, like, there's less
Okay.
elderly people.
Let's go population. I'm gonna go like countries. Population of countries.
It's like, there's
Right?
less older people
Right?
and
There's
less
a lot of little countries. There's a lot of little countries. So there's a lot of countries that might have like small frequencies, right? Okay? But then you've got like China over here that has a ton, right? You know, like one country that has a ton of people all the way over here. Does that make sense? Okay? What do you mean? No. So frequency would be like the number of countries. And this would be the population of those countries. Right? So one country has a population that's way, way, way out there. Right? There might be like another country. I don't know. What else is heavily populated? India, the United States, Japan. I don't know. I feel like the United States would be more heavily populated than Japan, but I don't know.
I don't have big plan.
I don't know. But anyway, so like I could see how it would be right skewed because there's a lot of little countries. So there might be like 14 countries that have like a population less than 500,000. I don't know. You know, like that type of thing happening. I like that population. That would be good. Anything else we can think of?
What do you think about?
I don't know.
You were talking
This one's
about-
hard for me to come up
I
with.
was talking like how many like 5-year-olds there are in like a country and how many like 89-year-olds there are in a country. I don't know.
She was talking about like
Because I
ages.
feel like we
Age of third world countries where you have like a lot of little kids and then not a lot of older people because they don't live that long. I don't know.
Thing, like, I don't know. I feel like we watched it in school one time. But there's this one country, and this is gonna sound bad, but I felt like it was like China or Japan, somewhere like that. India, I don't know where. But like because of their jobs, there's so many people who are like focused on like their jobs and making money.
That was like Japan or something
Yeah.
like that.
And like there's like no little kid like new
There's some
generation.
country that's
Make sure that
like,
doesn't go to
all
sleep.
older
Okay.
generation.
paying people more money to have more kids.
Yeah, because the population.
India has
We definitely watched that in stress class.
Yeah.
Stress class.
No one wants to have babies in Japan. 'Cause they don't wanna
Too
go.
busy with that medical field.
Because I got too many boys now.
Let's
just must suck to live in
see. I don't know.
Ain't nothing wrong with that.
Skew. What are we doing? Skew to the left. Skewed right. Positively skewed.
What do we got going on here? Ain't no-
Oh. Okay. Here we go. I got one. Ready? What do we got going on here? Income.
Can you erase my picture?
Yeah.
Yes, so.
Income. Is income right skewed? What's the lower bound for income?
12.
What?
12.
$12,000. $0 is income. Like you can't, you can be in debt. I'm not talking about your bank account. I'm talking about the money that comes into you yearly, right? At the very least, you can make $0, true? Okay, $0. So we're left skewed. There is quite a few people that make like less than $50,000 a year, and there's like not a lot of people up here making the billions, right? So that would be a good one for right skewed is income. Okay, that's one thing that they say. All right, they only give one example. Anyway, okay, questions about this of when that might take place? Okay, let's go to this right here. Skewed to the right, skewed to the left. Go to the top of the next page.
Can you paint those nails blue, please?
What?
Paint the nails blue.
Here's skewed to the right and skewed to the left. Positively skewed, negatively skewed. And this, like, positively skewed, I'm thinking positively skewed, that's more on the negative side. Negatively skewed, that's more on the positive side, but it's the backwards. It's backwards of what you think, okay? You like his snail reference?
I like this.
Okay.
Can you like
Otherwise, there's feet. What?
Can you paint the toes?
Paint the toes.
Blue.
Whoop. 1, 2, 3, 4, 5. Oh, what color are we painting the toenails?
I'm just gonna.
blue? Like the dark blue.
We're teal. We're painting some teal toenails.
Like yellow.
Oh, cute. Oh, cute.
Like Helen.
1, 2. We got an idiot toe going on here. 3, 4, 5. Oh boy, those are some real ugly toes. 1, 2, 3, 4, 5. There you go. There's my feet. Okay. Right skewed, left skewed. Right skewed, highest frequency. On the left. Left skewed, the highest frequencies on the right side of the graph. Okay, so it's the opposite of what you think. Or maybe it's the same as what you think if you're Jake Hodson. It's the same as what you think, right? There you go. Highest frequencies. There you go. There you go. Do I ask you some normal distribution questions? Okay.
Here's our homework. Here you go.
All right, ready for this? Okay, listen to this real quick. I don't think I ask you any normal distribution questions, but listen to this real quick. Okay? Here's the way that this works. Normal distribution. Nope, I don't. Okay? Let's talk about normal distribution. I'm just going to hit on this real quickly, okay? Shh. Listen. Are you listening? Okay? This is something called a normal quantile plot. We will do this in chapter 10. A normal quantile plot. It has to do with like a scatter plot and the way that this works, okay? So what's happening here is they will find like the standard deviation and they will figure out, actually they'll calculate what's called a z-score, okay? So you have your average value, and let's pretend your average value lives right here, right? So this is the average, right along that line, okay? And then you have your x values down here, and you say this dot right here was like -1, which was 1 standard deviation below average. Maybe this person scored below the average, okay? This person is scoring like almost 2 standard deviations above average, right? Okay? And so the way that this works is if you graph it, you will get a normal distribution that will have a normal quantile plot that follows kind of a straight line pattern, because you'll have some that are down here and some that are up here, and it's following a normal straight line pattern, okay? Let's go to the next one. That's for a normal distribution. When you convert it to a normal quantile plot, which we'll do in chapter 10, you have that going on. This is not a normal distribution, okay? Here is my average. And I have a lot of values that are being plotted here, which means a lot of people are below average. I've got one up here that's way above average. This is not following a straight line pattern. It's not really following any pattern. It's kind of a weird thing. It might be following an exponential function. I don't know. But that is not a normal distribution. Okay, another thing that is not a normal distribution, this kind of looks like a sine wave. You see that? It's a sine wave. Okay? So it kind of looks like it's following a straight line pattern, but it is in fact doing a curve. And that is not a normal distribution, okay? Again, we'll talk about normal quantile plots later on, but thinking as this being average, like these people are at the values that are above average, these people are at the values that are below average by a certain number of standard deviations, and we'll talk more about that later. But that is what happens when you have distributions that are normal and not. What?
Have you seen like the lapse time?
Yeah, of the sun. Mhm.
Like pattern in the sky?
Okay, so as far as it comes to homework, here you go. You have
Explain number one.
explain number 1. I don't know. Heights of adult males are normally distributed. Got it. I'm drawing this picture in my brain. If a large sample of heights of adult males is randomly selected and the heights are illustrated in a histogram, what is the shape of the distribution?
Normal. Just draw it.
This.
You just
What's
draw
the
it.
shape? I don't know. You can draw a picture. Or you can say bell-shaped curve or something of that nature, right? If they're normally distributed, that's what the histogram, the shape of it's going to be. Yep. Sounds good. Okay. All right, there you go. There is all of the things. You have to actually, they give you the frequency table on number 9, and they just make you put it into a histogram pattern, kind of like we did at the very beginning of the notes at the top. Okay? Do you have questions? Do you have questions before I stop? No?
Good. You can end it.
All right.